So, proximate analysis. We conduct a proximate analysis on food to determine its macronutrient and also the moisture content, which is essential for creating accurate nutrition labels, ensuring food qualities and safety, and complying with regulation. This analysis provides a foundational understanding of the food composition, including moisture, ash, protein, fat, and carbohydrates, helping manufacturers and consumers inform decision. So the objective of this project are to conduct a proximate analysis on a food. Second one is determine energy content of the food sample, and the last but not least, compare the experimental values with the nutritional labels. So to determine the protein in the food, we use the Kejeldah method. So this method include 3 steps, which are digestion, distillation, and titration. So after we do the Kejeldah method, we have to use the calculation. We have to use the formula to find the n value in the food. That's how we determine the protein content in the food sample. So for the protein, we got 33.96 kilocalories for the food sample of Biscuit Seng.
Today, I will explain about the methodology for moisture and ash analysis of our proximate analysis. First, for moisture content, this test was done to find out how much water is present in the sample. We used the oven drying method where the biscuit sample was weighed, then heated in a hot air oven at 105 degrees Celsius until it reached a constant weight. The difference in the week before and after drying show the moisture content. Our result was 1.49%, which indicates that the biscuit has a low water content, meaning it's more stable and has a longer shelf life. Next, for ash content, this test determine the mineral composition in the sample. We used the muffled furnace method where the sample was burned at about 550 degrees Celsius until only mineral residue remained. The percentage of ash was then calculated based on the final weight of the residue. Our result was 1.75%, showing that the biscuit contained a small amount of inorganic mineral, which is normal for processed food.
Next, I will explain about the fat analysis. So, the average fat content of our sample was 27.54%, which was determined using the Soxhlet method. So, this method uses an organic solvent, usually petroleum ether, to extract the lipids from the sample. Fat plays an important role in contributing to the energy, texture, and flavor of the product. However, having a high fat content can also reduce the product's shelf life due to oxidation. Finally, any small variation from the label value might happen because of incomplete extraction or solvent loss during the process.
So for this slide, I will talking about the fiber analysis and its moisture content result. The sample moisture content was 1.49%, which indicates a low water level. This is a good sign because low moisture means longer shelf life and lower risk of microbial spoilage. In other words, the food won't go bad easily. From the result, we can conclude that the sample is stable and suitable for storage, since microorganisms usually need water to grow. However, there may be minor differences in result due to incomplete drying or volatile loss during heating, which can significantly affect the accuracy of the measurement.
For this slide, we compared our experimental result with the nutritional level of the product. Overall, the result of our proximate analysis were quite consistent with the values stated on the label. This shows that our experimental procedure was done accurately and the sample used was representative of the commercial product. However, there were some slight differences in the values. This might be caused by human error, such as poor sample handling or because of different methods used of proximate analysis. For example, as mentioned by Pritika Bandari in 2021, minor handling issues can lead for variation in result.
Next, we have the impact or importance of this analysis. First, it helps determine the nutritional value of food. This is important to know how much nutrients the food contains. Second, it helps assess product quality since it indicates the food freshness, purity, and consistency. Third, it can predict shelf life, meaning we can estimate how long a product can last before it spoils or before microbial growth happens. It also supports research and product development by providing baseline data to compare samples, improve methods, and enhance product performance. Lastly, it ensures regulatory compliance, helping food procedure meet labeling laws and quality control standards set by food authorities. Even though the analysis is useful, there are still several challenges and possible errors. First, lack of specificity. The analysis grouped substance into broad categories, so it doesn't identify the exact compounds in each group. Second, sample preparation. If the sample is not prepared properly or consistently, it can affect the result significantly. Third, incomplete nutritional picture. Proximate analysis only gives a basic overview of macronutrients, not the detailed composition. Then we have method variability. Results can change depending on the method or condition used in the analysis. And lastly, incomplete combustion. Sometimes non-protein nitrogen compounds can cause estimate error and reduce accuracy. So overall, even though the analysis gives useful information, it is important to control this factor to ensure reliable results.
The proximate analysis experiment successfully determined the basic composition of the sample by measuring its moisture, ash, protein, fat, crude fiber, and nitrogen content. These components together provide an estimate of the sample's nutritional value and overall quality. The result indicates the relative composition of nutrients and non-nutrient materials present which are essential for evaluating the sample's suitability for consumption. Thank you.